Hello students, today in the second video of laws of motion we'll continue with uniform and non-uniform linear motion. Here in this table you can see the distance covered by Amar, distance covered by Akbar and distance covered by Anthony is shown in table as per the time student. So here when you will see, you will find that the distance covered in first half an hour from 5 to 5:30 is 20 kilometer. The distance covered by Amar in first half an hour is 20 kilometer. By the Akbar is 18 kilometer and by Anthony is 14 kilometer. In second half students, in second half the distance added is 20 and it becomes 40 in case of Amar. In case of Akbar, more 18 km is travelled and the total distance becomes 30. In Anthony case, more 14 km travelled and it becomes total distance 28 kilometers students, 28 km. Now next half an hour. In next half an hour, again Amar travels the same distance 20 km and the total distance becomes 60 km. Akbar travels only 6 kilometers students here. First half Akbar travelled 18, second half Akbar travelled 18, but in third half the distance covered by Akbar is only 6 kilometers students. Whereas Anthony, when we'll talk about Anthony, the distance traveled in next half an hour is again 14 kilometer. So here when you will see the distance traveled by Amar, Akbar and Anthony, here the distance traveled by Amar after each half an hour is 20 kilometers students. When you will see, you will come to know here distance traveled by Amar, Akbar and Anthony in each half an hour. You will come to know the distance traveled by Amar in first half an hour is 20, then next half an hour again 20, it becomes 40, again 20 it becomes 60, again 20 it becomes 80, and this way the total distance traveled is added up with the 20 kilometers students. So here speed is constant students, here speed is constant, but in case of Akbar, when you will see the distance traveled initially first 18 kilometer and then again 18 kilometer, total 36 kilometer. Later on only 6 kilometer per half an hour, and then later suddenly here speed decreased to 6, and now here speed again suddenly increases, and 42 plus 28 it becomes 70 kilometer. So here speed distance traveled is 28 kilometer, initially 18 then 6 and then 28. So here when you will see the distance covered by Akbar is not same speed is changing students, speed is changing, whereas Anthony also travels with the same speed 14, 2s are 28, 3s are 42. Here 14 is added up, and each half an hour distance traveled by Anthony is 14 kilometer only. So here Anthony and Akbar they travel with the same speed, whereas Anthony and Amar travel with the same speed, and Akbar, in the case of Akbar, he is increasing and decreasing the speed. That means he is using accelerator and brake, and that is the reason we can say the motion of Amar and the motion of Anthony are uniform motion, whereas the motion of Akbar is not a uniform motion, students. So this is about uniform and non-uniform motion. In short, if I have to explain, I can say if the speed is constant, distance covered by the traveler is constant per unit time, we can say the motion is a uniform motion. If the distance traveled in each time interval is not same, if the distance traveled is not same per unit time, then we'll say the speed is not constant and the motion is not a uniform linear motion. Let's move ahead, students. So here definition is there with you. If a object covers equal distance in equal interval of time, it is said to be moving with uniform speed, students. Uniform speed. If an object covers unequal distance in equal interval of time, it is said to be moving with non-uniform speed. For example, the motion of vehicle being driven through the heavy traffic. When we are traveling through a heavy traffic, we always take care that someone may come in front of you, and that's why you always hold brake and accelerator and you use it. So when you are increasing speed and decreasing speed, when you are using brake continuously, the speed is called as non-uniform speed, and this is the example of non-uniform motion here, students. Let us continue here. In next, we are going to learn acceleration. We are going to learn acceleration now. What is acceleration, students? The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. Acceleration is change in velocity upon time. Change in velocity per unit time is called acceleration, students. In other words, if we have to define, the rate of change of velocity is called acceleration, students. So here, suppose initial velocity is u, final velocity v, and the time taken for change in velocity is t. Then acceleration can be given as final velocity minus initial velocity upon time. So in short, we can write a acceleration is equal to v final velocity minus u initial velocity upon t time. So here we are having formula for acceleration is equal to v minus u upon t, students. V minus u upon t. Now here let's check your brain power. When an object is at rest in the beginning of the motion of its motion, what is its initial velocity? So simply we can say it is 0. Why? Because it is not it started. It is not it started. So speed is 0 only. So here initial velocity is 0. When an object comes to the rest at the end of the motion, what is its final velocity? When the body will come in rest, the velocity will be 0 only. So here final velocity is 0 here, students. So let us continue. If the velocity of an object changes during certain time period, then it is said to have accelerated motion. An object in motion can have two type of acceleration. Students, acceleration are of two types. If the velocity changes equal amount in equal interval of time, the object is said to be in uniform acceleration. Students, if change in velocity is constant, per unit time, then the acceleration is called as uniform acceleration. If the velocity change in equal amount in equal time interval, the object says to be non-uniform. If unequal amount of velocity is changed, if change in velocity is not equal in equal interval of time, then it is said to be non-uniform acceleration, students. I'll give example of non-uniform acceleration. See here, students, when you will see, first we will talk about uniform motion. Here, students. Here distance, when you will see this graph, distance and time graph is shown over here, students. Now here in last slide we are talking about acceleration, students. When we are talking about acceleration, what we say there is change in velocity per unit time, and that is called acceleration. So here change in velocity may be positive or negative. If speed changes and there is increase in speed, change is called positive change, and the acceleration is called positive acceleration. If there is decrease in speed, again speed is changing, though speed is decreasing, velocity is decreasing, it is changing. we can say the acceleration is negative acceleration. And if suppose there is no change in velocity, if suppose there is no change in velocity, it is said that acceleration is a zero acceleration. Students, please remember, acceleration is also of three types according to change. It may be positive, negative, or zero acceleration. At the same time, acceleration may be uniform acceleration or non-uniform acceleration. Uniform acceleration means change in acceleration is constant per unit time. And if non-uniform acceleration means change in acceleration is not uniform, change in acceleration is not uniform. That means accelerations increase in speed or decreases in speed per unit time is not constant, then it is called as non-uniform acceleration. Students, let us move ahead. Here we are going to discuss about distance time graph for uniform motion. Distance time graph for uniform motion. So there, y-axis we are having distance, x-axis we are having time. Time is in second and distance is in meters. Students, scale we will take scale as per the table data given here. Here the time in seconds is given for the distance traveled in meters. There is some car or some vehicle which is traveling with the speed, with some speed, and the time and distance record is maintained over here, and this is given in our data in table. Here initially when the time is 0 second, distance traveled is also 0. So here our point is at origin. Now second point, when time in seconds is 10, the distance is 15. Time in second is 10, distance is 15. Students, so 15 should be between 10 and 20. Here when you will see 0, initially 0, 10 and 20. So in 10 and 20 in between somewhere it should be 15. Students, it should be 15. So I'll take 15 in between 10 and 20 here, and our point will become 15, 10 and 15. Next is 20, 30, 20 and 30. So here our point is here 20 and 30. So I'll just mark point 20 and 30. Later on 30 and 45, 30 and 45, 30 and 45. So 45 must be between 40 and 50, 40 and 50, 45 must be there. So we'll take 45 in between 40 and 50, 40 and 50. Students, and we'll get point somewhere here. Students, so this is our next point. Now 40 and 60, here 40 and here 60. So here our next point is there, 40 and 60. Students, 40 and 60. 50 and 75 in the same way we'll get 50 and 75 somewhere here, and then 60 and 90, 60 and 90. Later on 70 and 105, 70 and 105. So when you will draw a line, you will get a straight line. Students, here you will get a straight line. So when you will get distance time graph as a straight line, the motion is called as uniform motion. The motion is called as uniform motion. Otherwise, in other words, we can say that the distance time graph for uniform motion is a straight line. The distance time graph for the uniform motion is a straight line. So this is the graph of the uniform motion, distance time graph of the uniform motion. Same thing we can do for non-uniform motion. Students, non-uniform motion. Here non-uniform motion, as we took here. Students, one thing we forgot to do here, x-axis scale. When we are talking x-axis, 1 centimeter is equal to, here you can see it is 10 seconds. Students, 10 seconds, it is seconds. Students, and here one box is equal to 20 meters, 20 meters. So we'll write 20 meters in y-axis. Y-axis it is 20 meters. So scale you will not forget to write. In next one here, non-uniform motion. Same thing we'll do for non-uniform motion. So here when you will see x and y axis, the points are not plotted, so we'll have to write the points by our own. So our time, let us take like 5, 10, 15, 20, 25, 30, 35, and so on, students, and so on. Now here, so this is our time axis. When you will see the distance axis, y axis, let us take 10, 20, 30, 40, 50, like this we can take. If you want, we can take 5, 10, 15, 20, 25, 30, 35 also we can take, students. Here I have taken till 60 here, students. I have taken 60. So this is origin, students, 0 0. This is origin 0 0. Now first, initially the point is at the origin 0 0, students, 0 0. For phi it is 7, students. For phi it is 7. So simply we can plot 7 here. For phi we can plot 7 here, students. So let us plot 7. Sorry, this is 7. Now for 10 it is 12. For 10 it is 12, students. So I'll mark 12 for 10. For 15 it is 20. So 15, 20. Let us mark 15 and 20. And next is 20, 30. So for 20 it is 30. So we'll get point somewhere here. Let us plot point 20 and 30. Next is 25, 41. 25, 41. So let us point here, students. We'll get point 25 and 41. Next is 30, 50. 30 and 50. So here this is 30, 50. Next is 35 and 58, students. 35 and 58. Students, when you will see, now here the graph is not straight. The graph is not straight. So when you will plot the graph of time and time distance graph for the non-uniform motion, you will not get a straight line. You will not get a straight line. So you can say the distance time graph for non-uniform motion is not a straight line. Students. Let us continue and see ahead. Velocity time graph for uniform motion. Velocity time graph for uniform motion, students. Here when you will see, a train is moving with the uniform velocity of 60 km per hour for 5 hours. The velocity time graph for this uniform motion is shown in figure. Now with the help of the graph, how will you determine the distance covered by the train between 2 and 4 hours? Between 2 and 4 hours, students, if we have to calculate the distance, we are having two ways. One, directly we know that the distance speed is 60 km per hour. And this time between 2 and 4 hours is 4 minus 2, 2 hours. So here speed we know 60 kilometer per hour, and sorry, students, speed we know 60 km per hour, time is 2 hour. So we can calculate the distance is equal to speed into time, and we can multiply both 60 and 20. We can say 120 is the answer. I'll repeat again, students. Here when you will see this graph, you will easily come to know here speed is 60 km per hour. Speed is 60 km per hour, and speed is 60 km per hour, and the distance we have to find in between 2 and 4 hours. So time is equal to 2 hours, students. Time is 2 hours. So we can say distance is equal to speed into time is equal to 60 into 2 is equal to 120, students. So here by using formula we can get answer is 120, students. 120. In a same way, suppose Now I am not using the formula. I am not using the formula. Here we got the answer for first question. What is the distance traveled? Distance traveled is 120 kilometer. Distance traveled is 120 kilometer. Now second one, is there relation between distance covered by the train between 2 and 4 hours and the area of particular quadrangle in the figure? Here quadrangle formed here in this figure is ABDC. ABDC is a quadrangle, or we can say quadrilateral, formed in this figure, students. So here when you will calculate the area of this rectangle, it is length into breadth. It is length into breadth here, students. So here length is 60 here, students. You can measure this length is 60, and breadth again between 2 and 4 is 2, so we'll get 120 only. So again we are getting same answer. So here there is a relation. The distance traveled is equal to the area of this quadrangle, students. So for today, students, I'll stop here only. In next lecture, we'll continue with velocity time graph, and we'll try to finish this chapter in this next video, which I'll share with you very soon. Till that time, I'll say thank you to you all, and we'll meet in next video, students. Thank you very much.